which of the below is a solution to, and we have 1 over x squared plus x integral. Okay. So there really isn't a good set pattern for how you go about solving integrals. Usually you start with the most obvious, easiest solution, and then kind of work from there. So this isn't a power rule. We don't see something like x squared, x cubed, by itself as a polynomial. And the next thing we kind of look for usually is like substitution. And what you look for substitution is one thing is like an integral of another. So if we had like x squared, one thing is a derivative of another. I guess you can say it both ways. But so we had something like 2x over x squared plus 2x. We're like, oh, 2x derivative of x squared. Actually, probably have to have 2x plus 1. It's okay. We look for something kind of like that. We don't see that here. Next thing might be integration by parts, where you look at it and it's basically in two sections. You have one thing multiplied by another, and if one of those things you can basically take the derivative of it enough times and it will disappear, then that might be a good candidate for integration by parts. And we don't have that here because we have basically just one component. So for this then, what we're going to end up going for is partial fractions. You might look at this and think maybe a trig substitution because we have a squared. Well, for a trig substitution, you really want to see something squared plus something else squared. So for trig substitutions, you want to see something like x squared plus 4, x squared plus 4 square rooted, or x squared minus 4 square rooted, where this 4 just represents something that's a square. So this is going to be, we're going to try for partial fractions. And the thing with partial fractions is, back in algebra, you would combine denominators. And partial fractions is basically undoing that. Decombining denominators, maybe decomposing denominators. That sounds about right. Okay. So when you see that, though, you usually have one thing multiplied by another. In this, we have one thing added to another. So what we want to do then is we want to instead look at this as 1 over x times x plus 1 dx. Seem reasonable? Okay. So that's what we're going to do here. I understand. You're like, wow, that's kind of a magic leap that you took there. It is kind of a magic leap. And for integrals, at some point, you kind of just have to look at it and be like, oh, that's what it is. I know, that's terrible advice and really hard for someone to follow. But for integrals, that's kind of where you just do enough practice that you kind of recognize what's the best path to go down. So this one will be partial fractions. We start by writing it as a multiplication of two things. And we say that, all right, and there's various rules for partial fractions. I'm only going to go over this as what we need to know for this one. Okay, so we're going to assume that this is a over x, and this is all still, integral, plus b over x plus 1. And the idea here is we can choose a and b so that they can combine to equal this value over here. So the way I look at partial fractions, 1 over x plus 1 equals a over x plus b over x plus 1. And so then what I do is I rewrite the second section as a combined denominator. So we're going to do a x plus 1 plus bx. And this will give us a common denominator of x times x plus 1, which sees we're kind of going back to the beginning here. And so if we rewrite that again, we're going to have ax plus a plus bx over x times x plus 1. And then rewriting it one more time, we'll have a plus b times x plus a over x times x plus 1. All right, so now we look at the numerators. Change colors. There we go. So we know that our numerator here, all we have is 1. So the only thing we have that's not multiplied by an x here is a. So we know that a has to equal 1. Well, we know that there are no x's, so we know that a plus b has to equal, and I'll do it like this, times x equals 0 x's. Which means that a plus b equals 0, which means that a equals, negative b, which will then equal negative 1. Bam! So, now that we've done the whole process for partial fractions, we can go back up here and rewrite this as integral of, a is 1, right? 1, okay. 1 over x plus negative 1 over x plus 1 dx. Okay? And we know the integral of 1 over x is the ln of x, and the integral of 1 over x plus 1 will just be the natural log of x plus 1. So what we get here then is something along the lines of natural log of x minus, I just moved the negative sign down here, natural log of x plus 1. Yes. And then because of log rules, we can combine these. So this will be natural log of x over x plus 1. So I'm terrible with log rules, and it's the sort of thing where I can never quite remember them. So what I do is I try to pick up some numbers, just not random numbers, but it just take a second to kind of verify that this is possible, maybe, at least not wrong, with your calculator. So every time I do this rule, I usually do something along the lines of, well, does that mean that natural log of 6 minus natural log of 2 equals natural log of 6 over 2, which means I'm running out of space, which is natural log of 3. Is that true? Maybe, possibly. Let's check. Grab our calculator, and we'll do clear, natural log, ln of 6 minus ln of 2. And that gives us 1.098, natural log of 3, 1.098. Okay, so this doesn't mean that the rule is true, it just means that it's not obviously wrong. So this is probably going to be our answer. And look at what answers we have, and look, right here, this is it. Natural log of x over x plus 1. So this is how you do a partial fractions. This is a relatively simple partial fractions. You can see some of my other videos for more complicated versions of partial fractions. But this is the general idea. So the way you approach this problem is you look at it. All right, can I do a polynomial power rule? No, probably not. Okay, can I do a simple u substitution? Look for one thing that's a derivative of another thing. No, not really. Okay, can I take the derivative of something enough times until it disappears? If that's true, then maybe integration by parts. And then maybe trig substitution if you see one thing squared plus another thing squared. And usually pretty much towards the bottom of the barrel, then you start looking, okay, maybe partial fractions. And partial fractions is one thing multiplied by another thing and the denominator, which is what we see right here. It doesn't feel like one thing multiplied by another because we have the plus sign there, but we can factor out the x, and it becomes like that. And that is how you do partial fractions.